Why is an ion thruster? An ion thruster is a type of space engine that uses ions, charged particles, to create thrust and move a spacecraft through space. Unlike traditional rockets that burn large amounts of chemical fuel to generate thrust, an ion thruster is very efficient and consumes much less fuel, though it produces less thrust compared to combustion engines. How does an ion thruster work? Imagine you have a gas, such as xenon, inside a compartment in the engine. This gas is inert. It doesn't react easily with other substances, making it safe and stable for use in space. The ion thruster releases small amounts of xenon and then uses electricity to charge the xenon atoms. This charging process is called ionization, and it turns the xenon atoms into positive ions, atoms with more protons than electrons, giving them a positive charge. The ion acceleration process. Once the xenon atoms are ionized, the thruster applies a strong electric field, like an electric push, that accelerates the ions out of the engine at very high speeds, usually in the opposite direction of the spacecraft's intended motion. This process of expelling ions backward generates forward momentum for the spacecraft. Following Newton's third law, for every action, there is an equal and opposite reaction. Though the thrust generated at any given moment is small, the advantage of this system is that it can run continuously for long periods, gradually building up significant speed. Ion thrusters can accelerate spacecraft to much higher speeds than conventional rockets because they are incredibly fuel efficient. Where does the electricity come from? To operate the ion thruster, the spacecraft needs a power source. In space, this electricity typically comes from solar panels, which convert sunlight into electrical energy. This electrical energy is crucial for ionizing the xenon and creating the electric field that accelerates the ions. For missions to far-off destinations where sunlight is scarce, other methods, like radioisotope power generators, may be used. Advantages and disadvantages of an ion thruster. Advantages: fuel efficiency. Because ion thrusters use only small amounts of gas, they can run for a long time without needing a lot of fuel. Long duration. Thanks to their efficiency, ion engines can keep generating thrust for weeks, months, or even years. High final speed. Although the initial thrust is low, ion thrusters allow spacecraft to reach high speeds in space since the accumulated thrust over time gradually increases their velocity. Disadvantages: low thrust. They don't have enough force to launch a spacecraft from Earth's surface, so they must be brought into space by a conventional rocket. Requires electricity. Although solar panels can power the engine in space near the sun, as the spacecraft moves further away, sunlight diminishes, and additional power sources may be needed. Long acceleration time. Because of their low thrust, ion engines need quite a bit of time to reach a significant speed. Applications of ion thrusters. Ion thrusters are ideal for deep space missions and for station-keeping maneuvers in satellites and space probes. For example, they've been used in missions like NASA's Dawn probe, which explored the asteroids Vesta and Ceres in the asteroid belt, as well as in geostationary satellites that need position corrections to stay in their precise orbits. These engines allow spacecraft to change their trajectory very precisely and are especially useful in missions to destinations far from Earth, where low gravity in space means that a small, continuous thrust can lead to sufficient acceleration to achieve high speeds over time. The future of ion thrusters. With advancements in technology, ion thrusters are improving in efficiency and power. Researchers are exploring the use of other elements besides xenon, such as krypton, which is cheaper and more abundant. Hybrid systems are also being developed, combining ion thrust with other propulsion technologies to create engines capable of more versatile maneuvers. In summary, ion thrusters are an advanced propulsion technology that represents the future of long-distance space exploration. While they don't have the power to lift off from Earth, in the vacuum of space they offer a highly efficient and long-lasting way to move spacecraft and probes, opening possibilities to explore beyond our solar system.